All right, for 8.5 day one, we are going to start with some properties of logarithms. And so what I would like for you to do is look at numbers 1, A, B, and C. So I guess the letters, I should say, as a warm-up. Okay, so go ahead and pause your video and then get started, and then we'll go over those. So these are properties that you should have felt pretty comfortable with because we keep revisiting these over and over and over again, right? Remember when we have x squared times x to the third, we would add those exponents. So it would be 2 plus 3, which ends up giving me 5, right? Whenever it's division, we subtract them. So it would be x to the 6 minus 2, which is really x to the fourth. Now remember, if this were flipped, that would mean that it would be x squared over x to the 6. We would have x to the fourth in the denominator, because remember, it goes wherever the big one's at. And then when we have ones like letter C, x to the third squared becomes x to the sixth. Remember, this is just like writing x to the third times x to the third, which then you would add, which then gets you here. Okay, but you don't have to rewrite it like that. So let's talk about the properties of logarithms. So these are three important properties. So we have the product, the quotient, and we have the power. Okay, so those are the three big ones. The first one, whenever you are multiplying things on the inside, what's happening is the u times v becomes a plus in between them, which if you think about it, it's kind of like up here, okay? You are multiplying something, so you add. Same rules apply on the next one. We are dividing, so we would be subtracting. Okay, and what I want you to think about is this technically has a negative exponent if you want to move it to the top. So that's why you need a minus here. And you'll see in a second why that applies. Okay, and the last one is kind of like what we have above. It is your power. So when you have something raised to a power, you could throw that power in front, okay, to get rid of the exponent on the inside with your log. Okay, so vice versa, you could throw it as an exponent if it is out in front. Okay, so these are huge, huge properties as we move on. So we want to make sure that we get pretty used to it. Okay, so let's talk about expanding and condensing. So you're going to be asked to expand occasionally, and that just means that you want to make it as long as possible. So I want to try to come up with the longest version of what we have here. Okay, so essentially what you're doing is you're putting each piece together. So I'm going to write it with log base 2 and have the 4. And then I'm going to write it with log base 2 of x squared. And then I'm going to write it with log base 2 of y. And the last one is log base 2 of z squared. Okay, now the only thing is I need to just kind of look and see what I can do from there. Okay, first off, the first two are being multiplied. They are in the numerator, so that's going to be a plus. The bottom two are in the denominator. So like we were saying up here, it's kind of like having a negative exponent because they have to go to the bottom. So that means because they're in the bottom, they are both going to be subtracting. Now I know it gets confusing because technically these two terms down here are being multiplied, but they're still dividing the top part. So you consider them still being divided. So you want minus. Okay, so remember multiply means add, divide, or if it's in the denominator means subtract. Okay, now from here, the other thing that we need to start recognizing is that we do have these powers here that we need to get rid of. Anytime you have an exponent, you're going to throw it in front. Okay, so as of right now, I'm skipping the log 2 of 4 in blue. We're going to have 2 log 2 of x minus log 2 of y minus 2 log base 2 of z. Okay, now this is where the tricky part happens ish. Everybody always forgets this. Anytime you have log base number of a number, so how we have 4, you want to try to see if you can cancel these. And remember, the way that you can cancel it is if you have log base 2 of 2 to something. Okay, because if you type this in your calculator, or if you think about it what we do later with logs. I don't want to talk about that, but there's something that shows you that this actually just equals 1. Okay, and again, if you type it in your calculator using your math button, you can see that it is 1. And I can show you that later if you need to. But anytime you have log-based number of that same number, it cancels. So you want to try to see if this 4 can be rewritten with 2 as the base. Well, that's pretty simple. We should know that 4 is the same thing as 2 squared. So what really is happening here is essentially, you don't have to think about it this way, but you're bringing the 2 out in front, and the log 2 of 2 cancels. So your final answer is 2 plus 2 log base 2 of x minus log base 2 of y minus 2 log 2 of z. Now, a lot of you are probably thinking, okay, well, why doesn't this cancel? It's because the 2 needs to be where this x is in order for it to cancel. It has to be log base 2 of 2, not 2 times the log base 2. Okay, there's a difference. So that's expanding. And that's about as complicated as it gets. So if you were able to follow along for the most part, then you're going to be pretty good to go. So let's think about condensing. That means this is a really long one. I want to make it short, right? Well, forget about the 3 for a second, okay? If we look at this first part, there's really nothing to do, right? So that can stay log base 2 of x. But over here, we have a 4 out in front, and we're going to throw it as an exponent. So this becomes 4 log base 2 of, oh, let me try that again. This becomes plus log base 2 of y to the 4th. Okay, now again, this log base 2 of x can stay. And now we're thinking about this first term, right? In order to just get a number, we need our log base 2 to cancel. So that means we need to have log base 2 of 2 added to the 3. Okay, now again, anything in front goes as an exponent. So we're really thinking about this as log base 2 of 2 cubed. Well, hopefully we're recognizing that 2 cubed is actually 8. So now we just need to pay attention to what's going on between these. I want to write this so there's just one log base 2. Well, 2 to the 3rd is 8. And then we are multiplying all of these because there is an addition sign between all of them. So we would have log base 2 of 8xy to the 4th. So we're going to keep practicing with expanding and condensing. Starting with these, we want to expand the following. So again, I want to rewrite them. Log base 3 of x squared, log base 3 of 9, log base 3 of y cubed. Okay, now after you rewrite each piece, you can start looking at what can happen in all of them, right? So this first one, I have an exponent, so let's throw it out in front. Now the 9, hopefully we are seeing, right? We're going to try to cancel that log because I can rewrite that as log base 3 of 3 squared because 3 squared is 9, right? So you can throw that 2 out in front and the log base 3 of 3 cancels. So you're left with just 2. And then we have our last one, which again, we can see, I didn't mean to put those pluses. And then we can see that they have an exponent, so we're going to put the 3 out in front. And then we just have to focus on the signs between them. Because the 9 and the y cubed are in the denominator, we need to have minuses in front of both of them. For the next one, we have log base b of 3b squared and then the square root of x. So we have log base b of 3, we have log base b of b squared, and we have log base b of the square root of x. Well, the first one, log base b of 3, I can't do anything to that. But the next one I can, right? Again, we have a base that's the same as the base that it is being raised to, right? So we have log base b of b. So those end up canceling, and you're left with just 2. And this last one, we need to think about the square root of x. The square root of x is really something raised to a power. It's x to the 1/2. Remember, it's like having a 2 out in front, and we put it underneath the exponent. So because we have this exponent, we could throw it out in front. So we have 1/2 log base b of x. The only thing left to do is to worry about the signs. All of these are being multiplied, which means we would just add when we expand. So we're going to work on condensing now. So when I look at this first one on number 5, all I see is I know that this needs to become a squared. From there, there's not much to do other than throw it all together. So we have log base 2 of x, and then it's minus y and minus z squared, which means both of those two are in the denominator. So then we are done. On number 6, we have a solid number, which means our log canceled. So that means that this one would have been log base 3 of 3 to the first. Or you could think about it as 1 times log base 3 of 3, and then throw it as the exponent. The next term, we have 1/2, which needs to go with the x. So we have log base 3 of x to the 1/2. And the last one doesn't change at all. There's nothing to go on there. So we can start throwing these together. Log base 3 of 3 times x to the 1/2. But remember, 1/2 is the same thing as the square root. You do need to rewrite it as a square root if you can. And then in the denominator is going to be y because there is a subtraction there. So it needs to go in the denominator because of the negative exponent it would have. So at this point, I encourage you to pause the video and try these on your own, and then I'm going to go through them pretty quickly. So for number 7, I would have log base 4 of 16 in the start. And hopefully we recognize that that actually goes to log base 4 of 4 squared. And if you throw the 2 out in front, we're really just talking about 2. Then I would have added 4 log base 4 of x because I need to throw that 4 out in front. Then it would be minus 2 log base 4 of y because it's in the denominator. And then minus log base 4 of z. On the next one, we have log base 5 of 25 plus 3 log base 5 of x. We should recognize that this becomes something different because I can rewrite 25 with base 5. And it goes away, and you're left with just 2. If we were to condense the last two, the first one, remember, we were thinking as 2 log, and then we needed the logs to cancel. So in order to cancel, it would have been 4 and 4, which really is talking about log base 4 of 16, because it would be 4 squared. The next one would become log base 4 of x to the 4th. The next one would be log base 4 of y to the 2nd. And the last one would just stay the same. So if we throw it all together, we would get log base 4 of 16 times x to the 4th. And then your y squared and your z to the 4, or just z, would be in the denominator because it's a subtraction in front of them. So number 10, same deal with the 2, right? It's 2 log, and then we knew that our logs canceled, so it would be 5 and 5. And then we're adding log base 5 of x to the 3rd. So this is really talking about 5 squared, which is 25. So we have log base 5 of 25x to the 3rd. If you noticed, we actually just did the reverse. We went back and forth. Number 7 was number 9 backwards, and number 8 was number 10.